Hello guys, welcome you all for this end-to-end session of data science where we're gonna learn everything that you guys need in order to become a successful data scientist. It is a combination of AI, ML, DL, NLP, artificial intelligence, everything, right? So artificial intelligence, machine learning, deep learning, computer vision, and then generative AI, everything we're gonna learn. So in order to become a successful data scientist. So I think we have done nearly 100 plus sessions, guys. Okay, so we are learning a lot. We are every day we are improving. So hope the same thing for you guys. So if you guys stuck anywhere, if you guys have any doubts, just ping us in the comment section. We will take up and we will solve your doubts. Okay. So yeah, that's the thing, guys. So today the session is all about the coding part of DBSCAN clustering, guys. As always, make sure that you guys watch all the previous session videos so that you can have a better understanding of what we are talking. Okay. So that's the thing. And before coming to the session, it's a coding part of DBSCAN. We have done the black box theory concept of DBSCAN in the previous session. Okay, previous two sessions. Make sure you guys watch those sessions. So yeah, that's the thing. And one more thing, guys, because like every day we are uploading a new video. So if you guys doesn't subscribe to our channel, please subscribe to our channel and press the bell icon so that you can get a notification whenever we upload a new video. So yeah, that's the thing, guys. So without wasting any time, let us jump into today's session. So today's session is a coding part of DBSCAN. Okay, guys, and one more thing, the IDE that you are seeing right in the screen, that is a collab IDE. We have introduced you. We have gone through a complete walkthrough of collab ID in the Python session. So if you guys doesn't watch the session, please watch the session so that you can have a better understanding of how to run it, how to load the data, what are the things there, what is this actually. Okay, everything we have discussed. So make sure you watch that video, that session. Okay. So yeah, guys. I hope like this is what everything I need to convey to you before going for this session. Let us go to the session. DBSCAN clustering. Hope you guys watched the previous two session videos. If you guys doesn't watch, let us give an idea. I give an idea to you. Okay, what is DBSCAN? So simple thing, it is a density based clustering technique where it can cluster the data point in any shape it needs. Okay, rather than like going for a spherical shape, or like we need a tree for creating cluster. No, this DBSCAN can create cluster of any shape and size. That's a major advantage of this DBSCAN. It is more likely used for anomaly detection and outlier detection. So hope you guys can get a gist of what is DBSCAN. Okay, let's move on to the coding part. Okay, so we're gonna import the necessary libraries as always, like NumPy, which is used to perform the mathematical operation, pandas, which is used to perform something like in order to treat the dataset in the form of a data frame, that is a table format. sklearn dataset, sklearn, I'm just importing dataset because I'm going to use the iris dataset. You guys already well versed with this dataset. Okay, next I'm just you're loading the scan.str from sklearn.preprocessing, and from clustering I'm just using this dbscan. That's it. Okay, then for plotting I'm just using matplotlib.pyplot as plt, and then for metrics I'm using silver score. Okay, so that's everything that I need in order to proceed with this clustering, dbscan clustering. Okay, so now moving on, I'm going to load the dataset. So it is a dataset which is available in the sklearn. So dataset.load iris, which will load the dataset to the iris variable, and then iris.data, which is our input, whereas iris.target is our output. The simple thing. Okay, hope you guys can understand. Once I print iris, you guys see we hit as a data. So we can say this is sepal length, this is sepal length, sepal width, petal length, petal width. That's it. Okay, we will be having four different features. Based on that, we need to predict what kind of species it is, whether it belongs to Setosa, Virginica, or vesicolor. That is 0, 1, 2. So based on the sepal length, sepal width, and petal width, we're gonna find what species the flower belongs to, whether it is Setosa, Virginica, and vesicolor. Hope you guys can able to understand. Okay, because like I hope like this is the, I think 6 to 7 times we are seeing this data set. Okay, in order to make you familiarize and make the concept very simple, I'm just using the same data set, more or less. Okay, now so this is our input, it is data, and this is our target, and you can see the frame is none, and yeah, here you can see the target values: Setosa, vesicolor, and Virginica. And then I think where we are having, okay, here we are having the attributes. We are having number of attributes is 4, and here the attributes name: sepal length, sepal width, petal length, and petal width. Hope you guys can able to understand the gist of what is the data set. Now moving on, this is my x. Okay, so we are having sepal length, sepal width, and petal length, petal width. So we are having 4 columns. Within a list we are having 4 entries. We can say it like this: We are having a multi-dimensional array. Each and every single list inside the array which says we are having 4 entries for it. That's it. Okay. Now this is my input. And moving on, let's see what is my output. Yeah, 0, 1, 2. Virginica, vesicular, Setosa, vesicular, and Virginica. Okay. Now I'm going to print the shape of X. Okay, I'm going to summarize the dataset first of all. Let us print the shape of X. We are having 150 rows and 4 columns, whereas the unique value in target is 0, 1, 2. Like Setosa, vesicular, and Virginica. Now, moving on, let us normalize this dataset. I'm going to import the standard scalar. That is, I'm going to apply to the variable called as scalar. Scalar dot fit transform of x, and then I'm just passing to x scale. So this is what the x scaled value. You guys can see here we are having the values ranges from -9 to 9. Okay, but previously we are having the input value. You guys can see, right? The first column has the digit of 5, whereas the last column has only 0 point values. Okay, point values, whereas we are having 1 digit values in the first column, which is higher than, very higher than when compared to the point values, 0 point values. Okay, so what happens means model thinks the first row, right, first column that we are having, that is sepal length, which has more importance when compared to the petal width, that is the last column. So that's the reason we are just generalizing. Rather than going for a big data and keeping it as a bias, we are making everything to a standard scale, that is -9 to 9 for this dataset by using the standard scalar. So that is what the result that you are having. So once we are done with it, and then we're gonna segregate the dataset into input and output. Since it is a clustering algorithm, already we have done for this x and y, and then the scaled x. So we need only input. Okay, since it is a clustering algorithm. Okay, so we're gonna apply the DBSCAN clustering. So we're gonna choose attribute values for epsilon and then min samples. So DBSCAN epsilon, guys, just ping in the comment section what is epsilon, and then I'm just giving the mean samples. Also ping in the comment section what is min sample, that is min points. You guys know, right? If you guys have watched our theory concept, that is a black box behind this DBSCAN, you guys already know what it is. Okay, hope you guys have know it. Okay, okay, whoever just wrote the right answer, that's great. Okay, wrong answer also, no problem, just ping in the comments. Okay, so what is meant by epsilon? So it is a radius inside which we will be having data points, which becomes a cluster. Min samples is the number of neighbors that we need to take in order to say it as a cluster. That's it. We need to fix these two values. Okay, I'm just fixing here 0.6 and min samples as 4. And then once I loaded a model with this parameters, I'm just gonna use this variable, that is model variable dbscan dot fit. Fit means we're gonna train it, and then I'm gonna train this scaled data, that is -9 to 9 data. Okay, x scale. Once I have done it, I'm gonna extract the clusters. So dbscan.labels, I'm gonna have the labels. So you guys see here, we are having 0, 1, 2, -1, and again we are having 2. So 0, 1, 2, and then -1. So you can see I'm just providing a list of it, array to list, and then set. You guys see these are the unique values that we are having here. Okay, 0, 1, 2, and then there is 1, -1. So guys, one thing, you guys never gonna see any algorithm which can show the outlier in this perfect format. You guys see here, we are having one more called class called as -1. That is the outlier. For this data, we are having only 3 classes, 0, 1, 2. That's it. But this DBSCAN is a unique algorithm which can find the anomaly detection. That is outlier. That is represented by using -1. Okay, you guys can able to understand, right? This is why I'm just insisting this algorithm better suited for anomaly detection and then outlier detection. Okay, you guys can now able to understand, right? Till this we have seen an algorithm which is able to predict whatever the numbers that we give. For example, here if we are giving a number of 3, but it give 4, that is the class is 3 and outlier is 1, that is -1, that is belongs to another class. So you guys can able to understand, hope. Now I'm going to visualize the data, simple thing. Okay, I hope like if you guys have watched our videos related to hierarchical clustering and then K-means, then it will be easy. So I'm just passing the scaled input to the scatter plot of matplotlib, and then I'm just giving 0, 1, and then 2. Okay, these are the clusters that we are having. Here also 0, 1, 2. So it's a first dimension, that is zeros, and then this is second dimension 1. I'm just fixing the size as 100, and first cluster color is red, and then I'm just putting a label as cluster 1. Like that, I'm just doing for 2 and 3. I'm just plotting the I'm just plotting the title. So DBSCAN clustering for iris dataset. So and then in X label I need the feature 1 standardize. Y label I need the feature 2 standardize. And then I'm just passing the legend plt.legend, and then I'm just showing plt.show. That's it. So hope you guys can able to see the screen, right? It's perfect, right? Guys, see, the red color belongs to cluster 1, blue color belongs to cluster 2, and then green color belongs to cluster 3. And there is no outliers. We have removed it because like we have plotted only 0, 1, 2. That's it. Okay. So this plot is plot in between the feature 1 standards and then feature 2 standards. And this is what the DBSCAN clustering for this iris dataset. Okay. You guys can see, right? So this is a simple way that we can use this kind of DBSCAN algorithm to perform clustering. Okay, let us move on. Okay, we're gonna calculate the silver score. So for calculating the silver score, it is like a accuracy for clustering algorithm. So silver score, I'm gonna pass X scale, that is the scaled input that we are having. Labels is the labels which is provided by the models output. Okay, you guys can see here, right? This is the models output. Okay, so now if I go through it, we are getting the silver score for these three clusters as 0.35, that is 35%. Okay, it is very poor, but like this is the entire flow, guys. You need to load your data, you need to just split it into input and output, and we need only input for the clustering algorithm, and we need to load the model and then just train it and get the inference. Okay, hope you guys can able to understand, right? So yeah, this is all about the DBSCAN coding part. So hope you guys able to understand. If you guys any doubts you can just ping in the comment section. We will take up and we will solve your doubts. Okay. So yeah, sir, over to you. Let's see. Sir will have more inputs. Yeah, sir, over to you.
Yeah, guys. So, guys, if you've come to this session, so go watch all the previous sessions and 5 to 10 times more than that, and build long-term vision for your career objective function. What you want to become with patience, consistency, persistency, and perseverance. So, write in the comment section if you have any feedback for our sessions. We will be improving each time. So, press the bell icon. Also, subscribe to our channels. Also, stay connected, tuned with us for this deep AIML data science program. So, DBSCAN clustering. The first step is again we have to import necessary libraries as per the model and the as per the data characteristics and the steps involved in the model. So NumPy, we have to import pandas, we have to import sklearn dataset, we have to uh, import again standard scalar, we have to import dbscan, matplotlib, and sklearn.matrix. We have to import like silver score and all, right? These are necessary libraries for each model. We have to do it. Okay. So then we have step 2 where we have to load the dataset X and Y, and then we get the feel of the behavior of the data output. Okay, let's move to the step 3. So we have the target variable and we have the X, okay, Y. Step 3, summarizing the data. Again, we have to summarize it, and shape of the data, X dot shape, np dot unique Y. So shape of the data is 154, unique target variable 01, label is 012. Step 4, pre-processing we have to do, normalizing the data. So as scalar dot standard scalar X scaled equal to scalar dot fit transform X. So X scaled, we have this data, which is the output. Okay. Then we go step 5. segregating the data into X, output Y. Okay, so then we have to go to step 6, applying the DBSCAN clustering. Okay, so we'll write DBSCAN equal to DBSCAN EPS equal to 0.6, min sample equal to 4, dbscan.fit x scaled. So you will see DBSCAN. So EPS equal to 0.6, minimum samples are equal to 4. Step 7 is extracting the clustering results, label equal to dbscan.labels. So labels, you can see the array at the outcome of data, the behavior. And then we have set list label, which is -1, 0, 1, 2, 3. Okay, then we have -1 is the outlier. So we check that. Then we go step 8, visualizing the clustering. We have to visualize now. Okay, that would be based on cluster 1, cluster 2, cluster 3, and colors are red, blue, green, and labels are 0, 1, 2, 0, 1, 2, 1, 1, 1, 2, 1, and then you have labels 0, 0, 0, 1, 2, 0. These are the X scale labels, and colors green, blue, red, blue, green, and cluster 1, 2, 3. Then we are going for DBSCAN clustering of iris dataset. Feature 1 standardized, feature 2 standardized, and then we'll see feature 1 and 2. DBSCAN, we have different clusters 1, 2, 3, with which already we have defined the colors red, blue, and green. So you can see and feel and have the behavior of the data. Here you can visualize how it looks like: green here, red, and then you have blue. So you can see maximum, the cluster 3 has maximum data points, cluster 2 has very less, least, and then you have cluster 1 has the second number. You can see, you can feel it and observe it and see the behavior of data. Let's move to the other step. Step 9, evaluating clustering performance using silhouette score, because we have to use silhouette score here to measure the performance accuracy. Silhouette score equal to silhouette score, X scale label, print silhouette score for 3 clustering, score, which is 35%, guys. So we have to keep iterating or cleaning data, or doing pre-processing, properly cleaning, or getting the right data from the right source with integrity, and then we'll improve our performance till we reach an optimal performance. Okay, so this is all. Keep learning deeply with deep understanding and meta level understanding. Now we are going deeper, guys. Okay, so understand these concepts properly, so that what and why, so that how is very important, and then you can do it. So imitate and mimic all these steps, build your own project based on this project, which will be an application. Do all the quizzes. We have more than 500 quizzes now live. So go and do. If you do all the quizzes, you will have a next level, deeper level of understanding about the concepts. And there are more than 200 algorithms which are in the quizzes in different permutation combinations, so that you can understand the concepts deeply. Their questions, their world-class companies question, Facebook, Google, Meta, all like best companies, Microsoft, their questions, what they ask in the quizzes. We have those quizzes and other questions also, so that you can deepen your knowledge, do this application, understand the concepts. So this is 360-degree learning with long-term vision. Deepen your skills. Thanks a lot. Keep learning.
Yeah, guys. So this is all about the coding session of DBSCAN. Guys, today we have seen a DBSCAN entire coding session from starting from importing the necessary libraries, loading the dataset, and I'm today it is nice, okay, right? Because like we have done each and every step to achieve this DBSCAN. Okay, so it is one of the clustering technique. More often, it is very useful whenever we go for a outlier. Okay, so we are following the same step like importing necessary libraries, loading the dataset, summarize the dataset, and then we have gone for loading the model, training it. Before that we have done the feature scaling. Once we have trained it, we have gone for something like testing kind of thing, and then we have discussed the labels, and then now we getting the initial like a visualization of how DBSCAN clustering works for this iris dataset. Okay, hope you guys have enjoyed. So if you guys have any doubt, just ping in the comment section, we will take up and we will solve your doubts. Okay, a simple thing, guys. So this is DBSCAN, and you are having data points like red belongs to one class, green belongs to another class, blue belongs to another class. So this is how DBSCAN works for this iris dataset. Okay, so you can tweak the parameter and play with it. Okay, so yeah, guys, that's it from my end. So thank you, guys. Thank you all. As always, we will all meet in the next session. Bye until next session. Bye, guys. Take care. We will all meet in the next session. Bye, guys.